Hi everyone, this is Tetsu, and this time we'll take a look at the ship scene that comes with Phoenix FD 2.2. We'll build the scene from scratch. We'll start with setting up the units, the dimensions and the speed of the ship, and once we have that, we'll create the Phoenix simulator and we'll start adding the nice stuff, which will be the foam and the splashes, and at the end I'll show you how I rendered this. So let's start. One of the first and most important things that a lot of people get confused with is the unit setup. And people often ask which are the right system units that they should use, and actually there is no such thing as right units. Because if you think about it, I live in Europe, so I'm used to the metric system. And it's easy for me to work with meters, but if you're located in, let's say, UK, you're probably used to the imperial units, and in such case it will be easier to work with feet instead of meters. So what's important to remember is that not the units, but the size of the object is what matters when you do simulations. So if you have a ship that is 150 meters long, that's correct. And if you have a ship that is 430 feet long, that's correct also. But if you have a ship that is 1000 meters long, or 3280 feet long, that's wrong. And Phoenix is designed to work with real sizes, and when you have the wrong sizes, you struggle a lot. So keep in mind that when you create your scenes, make sure that the objects that you put inside the simulator have the right size, and you'll see how much easier it is to work that way. So let's take a look at the current system units. And as opposed to the sample scene where one unit equals to 20 centimeters, that's in the sample scene. Here I changed one unit to equal to 1 meter, just for simplicity. And you'll see that because the ship has the right size in both scenes, the difference in these units here won't affect the simulation at all. So we'll see this later, and for now I'll just click OK to close that. And I also made the size of the home grid a little bigger, so I've come here to the grid and snap settings, and here under the home grid I've changed the grid spacing to 10 meters so that I can see it in the viewport. And for the size of the ship that is so important, I searched the web and used that page as a reference. And here they give the length, which is 154 meters, and the beam, which is 20 meters. So I've created a box to get the dimensions inside the scene, and this is the box with the length of 154 meters and width of 20 meters. And I made sure that the ship fits inside that box to get the proper dimensions. And I then just hit the box because I don't need it anymore. And I'll animate the ship now. So I'll turn on the auto key, select the ship, I'll move it on the y-axis. So let's say it starts from -200, and at frame 1000 it goes to 200 on the y again. So it travels a distance of 400 meters in 1000 frames. And by knowing these two values, I can find out the speed of the ship. So I'll use a calculator, and I'll divide the frame range, which is 1000 frames, divided by 30, because I am at 30 frames per second. So 100 divided by 30 results in 33 seconds. And if I take the distance that the ship travels, which is 400 meters, divided by 33 seconds, gives me 12 meters per second. And to get a better idea, I'll convert this to kilometers. So 12 meters per second to kilometers per hour. That makes 43 kilometers per hour. And if I open up the reference page, the speed here is about 56 kilometers per hour. So we are a bit slower, but I'll leave that. And I'll open the curve editor, select the Y position, the one that we just animated, select these two keys and set them to linear so that the ship travels with a constant speed. And I'll just clean these two guys by selecting the keys and press delete. We don't need those. We will need a simulator, however, so I'll create one now. Here in the create menu, standard primitives, Phoenix FD, and here's the Phoenix simulator button. So instead of creating one big simulator covering the whole route of the ship, something like this, I can make this simulator much smaller and make it covering only the area around the ship. So I'll go in here and shrink it on the X and also on the Y. And let's move this back. And notice that I am not centering the simulator to the ship like this, because I don't need to simulate this empty area at the front, because nothing happens there. And instead I want to pull this back and have this area here simulated, because I have some nice waves that will be created at the back of the ship, and I want to leave room for them. So I'll set this a little back, and I can also decrease the size on the Z, because I don't need to have all the bottom part of the ship inside the simulator. So I'll set this to half of what is it now, so 8, and I'll move the simulator up to make sure that I capture the waves at the front. So I can move it a little bit more, maybe less, and yeah, so that's the simulator. And if I scrub the timeline, you can see that the ship is traveling, but the simulator stays in place. That's because they're not linked together right now. So I can just use the select and link the simulator to the ship, and now they are moving together. This is a pretty neat workflow, because now with the smaller simulator I can have a better detail in less time. And don't forget, in order for this setup to work, you have to make sure that the inertial forces in the dynamics are turned on, and they're turned on by default, but make sure that this checkbox is checked. I'll increase the resolution to about 1,000,000 for now, and I'll also enable the liquids and the initial fill up, which I'll use to fill the container with liquid to a certain level. And I can again take a look at this page here to check the draft, and the draft is 9.4 meters. So I'll create a box to get an idea of these 9.4 meters, and let's take a look at the left view. And what the draft is, this is the vertical distance between the water line and the bottom of the hull. So you can imagine that this is the bottom of the hull, and the water line should be somewhere here where the paint border is actually. So I'll delete this, and now I know that my initial fill up should be somewhere around the paint border. So let's select the simulator and try it with the default of 50%. So hit start, switch to the left view, and this is a bit too much now, so let's set it to something lower, like 40, and try again. Okay, this is better. So let's switch the preview to mesh. I'll turn off all the other that I'm not using it now, and switch this to mesh. And I will also go here to the rendering and switch the mode to ocean. This pop-up appears where Phoenix recommends to use the static default geometry when rendering the ocean, and it will set it up for us, so hit yes. I will also set the ocean level to 40 as the initial fill up, and let's see what we have. I'll pause this for now because I don't like the wave here at the back. To make it more interesting, I'll unhide a box that I have prepared, and it's this one here under the liquid. and I'll use this together with the liquid source to create some nice waves at the back here. So let's create the liquid source. So here to the helpers, Phoenix FD, and pick the Phoenix liquid source, and I'll give this a blue color and switch back to gray again. And here click the add button and pick the box. I'll set the discharge to 14 and also the polygon ID to 1, so that we only emit from this front face here, and all these other faces are ID 2 and only the front one is ID 1. Okay, so my frame here is 55, so I'll simulate now to frame 54 so that we can compare the two frames, and hit start again. While this is simulating, I'll create a standard material for the mesh to be able to see it better, because right now it's a little too dark for me. So I'll call this standard, change the diffuse, hit OK, and apply the material. Okay, so it's done, and this is with the liquid source at the bottom, and this was the previous result without the liquid source. And you can see it's definitely more interesting now at the back, and also some nice splashes will be created here. Okay, so now I think I can come back here and increase the resolution. I want it to be somewhere at around 50 million, so let's try with 0.28. okay, and here in the dynamics I want to make sure that the conservation method is symmetric, and the symmetric is preferred for oceans, and especially in this type of simulations, because I want to have the waves that are generated at the front here to be relatively same on both sides. And the smooth conservation, for example, can produce waves that are very different from one another on the both sides. So we'll use the symmetric, and I will also increase the quality from 30 to 50, because in some cases the waves might reach the end of the simulator, and later when we add foam it stays like it's cut off here, and it's really easy to notice when you render it with the ocean. So here is one of the previous simulations that I did earlier, and you can see this is exactly what happens with the quality of 30. So by increasing it to 50, this shouldn't be the case anymore. I'll leave this to 50. I'll also set the steps per frame to 4 because the ship is moving relatively fast, and I'll rerun the sim now. Okay, so I paused the sim at frame 600 because I am pretty happy with the result so far. I have some nice detail with the 50 million cells, and here's the viewport preview. You can see there are some nice cutting in the waves at the front, and also I like how the waves attenuate before they reach the borders of the simulator. And I think we are ready now to get to the fun part, where we'll add the foam and the splashes. So close that and select the simulator. I'll enable the splashes by clicking the enable button, and Phoenix offers to create a shader for me, so I'll press yes. At first I'll just set the rate to 1 for the basic setup, and then I'll increase it. I'll create the foam from the splashes by setting the foam on hit amount to 1, and when I create scenes where I have both foam and splashes, I always like to create the foam that way because it makes sense, and in this case when the splashes hit the ocean they'll create the foam there. and that's really nice to have. I should enable the foam now from its own tab, and Phoenix will create another shader for us, but this time for the foam, and I'll just move it closer to the other one. And here in the foam tab, I will just set the rate to 0 to make sure that no foam will be created directly, so that now only the splashes create the foam. I'll decrease the resolution now for the setup stage. Okay, 1.5 million will give nice fast simulation times, and let's press start. And I'll turn off the mesh from the preview. Instead, I will enable the foam and the splashes preview. So foam and splash. I'll pause now and get back when I have some result. The first thing that I notice is that the foam is not living outside the simulator, so I will give it some outside life. Here in the outside life, I'll set this to 20, which means 20 seconds, and this will be more than enough. I will also give some outside life for the splashes, in case some of the splash particles reaches the end of the simulator. So here the outside life, I'll set it to 4. I don't think they will reach the end of the simulator, but just in case. So you can see now the foam lives outside the simulator. Now the foam flies too high, so I'll decrease the rise speed quite a bit, and I will also decrease the falling speed. The falling speed actually works as a drag force, which will be applied to the particles, and that will keep them down here in the simulator. I can also increase the air friction of the splashes, and I'll increase it quite a bit. Because when you have bigger splashes, like in this case, it's a good idea to increase the air friction, because you can end up with a single particle shooting up or flying too high around the base particles, and we want to keep them down there where the waves are. So that's why we'll set this to 100. Okay, so we are almost at frame 250. And what I noticed is that the size of the bubbles is too much, and you can see these bubbles are very big, and here at the front also. And when you compare this to the size of the ship, it looks strange. So you can see that the size of bubble right now is 30 centimeters, which is a lot. So I'll set this to 0.03, which means 3 centimeters, and I'll lift up the size of the big bubble slightly by increasing the variation up, and also I'll increase slightly the distribution so that I have less of those bigger bubbles. And let's take a look at the size of the splashes. Here I think I'll only increase the variation up, because variation in the size is always a good thing. And yeah, that's it for the size. There are the foam particles now with the smaller size. The one thing I can do now is I will decrease the bubble to bubble interaction, because the size of the bubbles is big enough to make them stick together, and I don't need it to be so strong, so I'll set this to 200. By setting it to a lower value, I will make the simulation run a little bit faster, because the bubble to bubble is an expensive effect to simulate, because you have to process the particles individually. And let's create the patterns. They will add some nice detail here at the front and at the back also. So I'll set the strength to 1, because I want them to form in less time. And for the size, 10 will be too much, considering that the ship is around 150 meters. And the reference images that I've found, this one here, you can see the patterns are quite small compared to the ship. and these guys here, and here's the other reference. You can see these tiny little patterns. So a size of 100th of the ship will be okay, I think. So I'll set this to 1.6, and I'll let this simulate to give it a time to form the patterns, and I'll see you again. The patterns started to form. If I pause this for a second and scrub the timeline, you can see that as the ship moves forward, it leaves the foam, and the foam starts to form the patterns. And you can see this behavior here. You can see how the foam is pushed away and starts to create the patterns. This will be more visible when we increase the resolution. And for now, I think I can decrease the half-life, because right now the foam seems to live forever, and I will set this to 0.5 and find the frame where I can restore. Okay, so here is a frame that you can restore the simulation. So I'll hit stop and restore with the new half-life, and see how this will affect the whole thing. The half-life of the foam did its job, and now the particles are dying off earlier, and they never reach the back end of the ship anymore. I like that, so I'll keep the half-life to 0.5. And this is the whole sim that we've gone through to prepare the settings for the high-res one. And this is what we've had. Before actually increasing the resolution, I will set the rate of the splashes to 10 to create more particles. And I've done some tests before with high resolution, and I found that birth rate of 10 will give me enough particle count, somewhere at about 3 million. I will also increase the threshold to 20, which will create the splashes only at the areas where the waves are forming and then crashing. I will also export the velocity channel for the splashes, so that I can render them with motion blur later. And I'll jump here to the grid again and turn back the resolution up to what we've had before. Okay, so 51 million. I'll hit start and wait for the whole sim to finish, and then we'll take a look at the rendering. And the sim finished. It simulated for 22 hours for 1000 frames, so a lot of frames to simulate there, but the waiting totally worth it. And I'll show you the viewport preview to see the result. So here it is. You can see the splash is created at the front of the ship, and they nicely attenuate before they reach the end of the borders of the simulator. And you can also see the foam is nicely spread on both sides of the ship thanks to the symmetric conservation. We also have some nice detail in the patterns, and also I like the backside where the waves are created. So I'll jump back to the scene now. Let's create some waves before we start with the rendering. So I'll select the simulator and go here to the rendering tab and enable the displacement, and I'll switch the type to vector so that I have a vector displacement. Now we need to specify a map in the slot here, so I'll open up the material editor and create a Phoenix ocean texture, which is here in the standard textures, and Phoenix FD ocean texture. So I'll give this a name, and the only thing that I'll change here is the wind speed, and I'll set this to 5 meters. And that's one of the beauties of working with real sizes. You don't have to change any of the rest parameters, they're already adjusted for us. So I can now just take the texture and plug it into the map slot and hit OK. And you can see the waves in the viewport. I can optimize the speed of the viewport to get some faster feedback when I scrub the timeline. open the preview tab, and for now I'll just turn off the mesh preview. I'll also turn off the splash preview so that I only have the foam visible in the viewport, and I will increase the detail reduction to 1. Now if I scrub the timeline, I can see that it's definitely faster. And let's change the material for the water. So I'll open the material editor. I will assign the material that comes with the sample scene. It's a simple liquid material and nothing special here, so I'll just select the simulator and apply this material. Let's hit render now. And we can see the ship and the foam, but to see the ocean we'll need some environment, so I'll stop this and I'll create a V-Ray sun. Go here to the lights, V-Ray, and click the V-Ray sun and hit yes for the V-Ray sky. Make this a little higher. Okay, and a bit more from the back, and I'll center the target to the world. I'll take a look from the camera this time and hit render again. And here is the ocean as well as the ship and the foam, but everything is too bright now, and that's because I don't use the exposure settings of my camera. But what I'll do instead is I will decrease the intensity of the sun. So I'll come here to the intensity multiplier and set this to 0.03, and I'll also check the invisible checkbox so that I don't see reflections of it on the ocean surface. I will also decrease the shadow subdivisions. We don't need to have 3 subdivisions because the shadow that the ship throws over the ocean is barely visible, so we don't need to spend much time for sampling that shadow. So I'll set this to 1, and I'll also open up the material editor and the environment and effects window, and I'll duplicate the default V-Ray sky that we created and hit OK. I'll specify intensity again of 0.03. I'll check the sun invisible here as well. So I'll hit render now again. Now it looks much better, but the ship is too dark now. So I'll create an Omni for that. So I'll press stop and switch to perspective view, go to the lights. Here in the standard I'll create an Omni. I'll center it here and I'll raise it up. Okay, a little bit more and move it more to the back. I won't enable the shadows here. I'll just set the intensity to something very low, like 0.1, and make this somewhere in the blue tone. So maybe something like this. Hit OK, and let's take a look from the camera again and hit render. And the ship now is illuminated better, and I also like the blue tint. I'll let this frame render to the end. Okay, and this is the rendered frame. I think I can still improve the look of the ship a little bit more by adding some ambient occlusion. So I will create a V-Ray ambient light. For the color, the same color as the Omni light, so I just copy this and paste it here. And for the light map, I'll create a V-Ray dirt map. So go to the maps, V-Ray, and V-Ray dirt. I'll call this ambient dirt and plug it here to the light map slot. Hit OK. Hit render. It's a little strong actually for what we need, so the phone starts is burnt out, and I'll stop this and I'll just set the intensity to something a lot lower, and the light map also, and let's render again. That's something that I was after, so I'll let again this frame to render to the end. Here's the rendered image, and the foam here that is in the shadows, it looks okay, but the one that is directly lit by the sun, it really burns out. So I will select the shaders, but first I'll color code them so that I can recognize them easier, and that's the foam shader, so I'll select it and give it a light color, and for the splash I'll give it a green. And I'm color coding these the same way as they are color coded in the simulator. So the foam is white and the splashes are green. So I'll select now the foam, and I'll lower the diffuse multiplier to 0.5, and I'll also switch the mode to point, since we are rendering it from a big distance, and we won't be able to recognize the bubbles, so this will only increase our render time, and that's why I'll switch to the point mode, and I'll select the splashes and do the exact same thing. So I'll set the diffuse to 0.5 and switch the mode to point, which will give us better rendering times. Another thing that I can do for the rendering to speed it up is I'll change the image sampler to fixed. I'll leave it as this to 3 subdivisions, and I'll also turn off the image filter. If I open up again the rendered image, this was rendered in 2 minutes and 40 seconds. And before I hit render, I will turn on the motion blur for the splashes. So I'll set the motion blur to force on, and here in the point section I will decrease the motion blur step to 0.2 meters because 1 meter will be too much. And now I can hit render. So from 2 minutes and 40 seconds, it now rendered in 1 minute and 30 seconds. And this is a pretty good optimization. And yeah, I hope you enjoyed this and learned some new things. And bye.